Hey guys, welcome to 2015 Level 1 Investigate Relationship between Table Equation and Graphs, which is 2015. I'm going to walk through the exam paper. So, question 1. A plant is growing on the surface of a pond. Hank notices the plant on day 1. 2 days later, Hank was worried about the plant and started measuring the area of the plant covered. Each day at 5 p.m., Hank measures the area of the water in square meters covered by the plant. He records his measurement in the table below. D is the number of days since Hank first noticed the plant, okay? So we're just going to fill out this table, okay? So as you can see, each day is doubling, so 4, 8, 16, 32, 64, 128. So each day the number doubles, okay? So multiply by 2, multiply by 2. So if we go backwards, we will divide by 2, okay? So on day 2, there'll be 2, and then at day 1, 2 divided by 2 is 1, so on day 1, it will be one area covered by the plant. Show how the area of the pond covered by the plant changes with time. Okay, so in this question, we're going to be plotting the graph for the area covered by the plant. Okay, so as D increases, area of the graph, not area of the graph, area of the plant will also increase. Okay, so plotting graph. So on day 1, we have a 1. So 1 area covered, 1 meter square covered. Day 2 is 2 meters squared. Day 3 is 4. Oops. So day 3 is about, that's too much. Day 3 is about 4 meters covered. Day 4 will be 8, so it just keeps doubling. Each day it will double. So just gonna plot out the graph here. On day 5, 16. So 16 should be around here. Day 6 will be 32, so be around here. Day 7 will be about 64, which is about here. And day 8 will be all the way up here, 128. So now all we have to do is we'll just connect these dots to make an exponential graph, okay? So it should look something like this. So if we... Sorry, my drawing is a bit messy. Dang it. Why can I... Sorry, guys. No, day 6 is 32. So okay, so sorry that's a bit messy. Just to get a rough idea, it just should look something like this. That's an exponential, okay? Day 0 should be 0. Sorry. So day 0. No, day 0 is 0.5. Sorry. Should be somewhere. Okay, so the graph should look something like this. Okay. An exponential going up, okay, and just drawing the graph out correctly will get you an achieved grade here, okay. Alright. The plant followed the same pattern of growth from the time when it was first noticed. What area of the pond was covered by the plant when it was first noticed? Explain your answer. So basically, when it was first noticed would mean like when Hank sees it on day 1, okay. So on day 1, Hank will come and see the plant, and on day 1 he'll start recording how much the plant is covering, okay. So basically on day 1, okay, so each day is doubling. So from day 1, if we work back from day 3, as you can see in the table, day 1 meter per 1 meter squared is covered by the 1 meter squared is covered by the plant on day 1, okay. So simply we're gonna say when Hank first noticed the plant, 1 meter squared has been covered. We will just say this is because 1 meter squared of plant was growing on day 1, when he first noticed the plant. Okay, so basically that's your answer here. And just saying the statement here, so saying 1 meter squared, and then just to get you a merit grade here. Okay, so yeah, so here that'll get you a merit grade. It's a merit question. To get an achieved, you're looking at just writing 1 meter squared. So just 1 meter squared here. So just 1 meter squared will get you an achieved. Okay, moving on. Give the equation that describes the area of the plant that is covered in the pond after D days. Okay, so that's basically referring back to our exponential right here. Okay, so as you can see in our table, okay, it's multiplying by 2, multiplying by 2, multiply 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 by 2. Okay, the equation for the basic equation for an exponential is y equals to y equals to a to the power of x. Okay, so as you can see, it's multiplying by 2, right? Okay, so no, it's actually not a to the power, it's k multiplied by a to the power of x. Okay, so k is a constant, and then a is the base multiplied by the power. Okay, so y equals, so as you can see, each day is doubling, right? So because each day is multiplying by 2, that means the base is 2. Okay, so that means a must be 2, so it has to be 2 to the power of something. Okay, so 2 to the power of 1 is 2, 2 to the power of 2 is 4, so 2 doubled is 4, then 2 to the power of 3 is 8, 4 doubled is 8. So as you can see, if the base is 2, so 2 to the power of something, and then it just keeps doubling by 2 as you increase the x, right? So the a must be 2. Okay, so if the area covered by the plant was multiplied by 3 each day, so let's say it was 1, then day 2 was 3, then maybe day 3 was 9, and then day 4 would be 27. Let's say, for example, it's increasing like this. Because each day is multiplying by 3, that means in this case, a must be 3. Okay, so just to get a better understanding of what I mean. Okay, so now we know y equals to k multiplied by 2 to the power of x. Okay, so now we're going to substitute 1 point into the equation to find what x is. Okay, so we'll just say, for example, a random point. We'll say when days equals to 4, area of the plant will be 8. Okay, so instead of using y and x, we'll use days, and we'll use area. Okay, so we're going to say area equals to k multiplied by 2 to the power of d. Okay, so now we're going to say we're going to say, for example, we're going to substitute d equals to 4 and a equals to 8. Okay, we're going to say 8 equals to k multiplied by 2 to the power of 4. So 8 equals to 2 to the power of 4 is 16, so 8 equals to 16k. So 8 divided by 16 equals to k, and therefore k must be equal to 0.5. Okay, so basically now we found our k value. Okay, so therefore we can rewrite our equation here. Okay, so therefore we can rewrite our equation as area equals to 0.5 times 2 to the power of d. Okay, so here this is our final answer here. Okay, getting all the way here to the final answer will get you an excellence grade. Okay, as getting a merit grade, so getting a merit grade is only getting this part of the equation. So only getting 2 to the power of d, so only getting this will get you a merit grade. Okay, but you need a 0.5 in front of the equation in order to get your excellence grade. Okay, alright, next question. If no intervention takes place, on which day will Hank first measure the area of the plant to be more than 500 square meters? Okay, so basically we're going to substitute 500 into the equation. Okay, so we're going to say 500 equals to 0.5 times 2 to the power of d. Okay, so therefore 250 equals to 2 to the power of d. So therefore, okay, actually, we should refer back to our graph of this question, okay? So as you can see, each day is doubling, right? So day 8 will be 128, so day 8 is 128. Day 9 will be this doubled, okay? So day 9 will become 256. So day 9 is 256. And therefore, on day 10, it will become 512. And 512 is more than 500, so therefore, you're going to stay on day 10. So therefore, on which day? So basically, you're just going to say on day 10, okay? And just writing day 10 will get you an achieved. Alright, moving on. Alright, Hank and some friends start removing the plant on day 9. The graph of the area covered by the plant from day 8, when it covers 128 square meters below, shows what Hank hopes will happen to the area of the pond covered by the plant. What is the equation of the area covered by the plant as shown in the equation? So as you can see, this graph here, this graph here, it's a linear graph, okay? So you know that the equation for a linear graph is y equals to mx plus c, okay? C is the y-intercept, and m is the gradient, okay? So how much is decreasing or increasing per day, okay, basically. Okay, so we're gonna... Okay, so basically, you know that this point here, this point is 128, and then after at day 13, the area covered by the plant is 0. Okay, so in between there are 1, 2, 3, 4, 5. Okay, so therefore Hank and his friends will remove the plant 5 times, and then the area of the pond covered by the plant will reach 0. Okay, so if he removes it 5 times, okay, so after 5 days, 128. So each day he will remove 128 divided by 5. And that will give us 25.6. So therefore, Hank and his friends, each day they will remove 25.6 meters squared of the plant, okay? So therefore, we can say y equals to 25.6 x plus c, okay? We're gonna say it's negative. We're gonna say it's negative 25.6 because the graph isn't increasing, it's decreasing. So each day the area covered of the plant will get smaller and smaller. So therefore, it's a negative relationship. So we're gonna say it's negative 25.6x plus c. C is our y-intercept. Okay, so as you can see here on day 8, it's equal to 128. So what will it be on day 0? So what will it be here? Okay, so basically, if we drag this linear graph back, right, we'll say 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days, 8 days. Okay, so we're going to drag the graph back by 8, okay? So we're going to say, because we found out our gradient is negative 25, it's negative 25.6. Okay, therefore, if we drag the graph backwards, so we're going to say 8 multiplied by 25.6 is positive because we're dragging the back. It is positive 25.6 because we're dragging the graph backwards, okay? So it's not going, so it's D is decreasing, not increasing, okay? So as you can see, if we drag this all the way back, okay, it will look something like this, okay? So like, so there'll be like a y-intercept, okay, when we're trying to find that y-intercept, okay? So basically, 8 times 25.6, that equals to 204.8, okay? And we're going to add that to the 128 that we had on day 8. And that should give you 332.8. Okay? So now we have our y-intercept, okay? So now we can say y equals to negative 25.6x plus 332.8. Alright, here's your final answer. And getting all the way here, that will get you a merit grade, okay? In terms of getting it achieved, it's either the correct gradient or the correct y-intercept, okay? So either one of these will get you an achieved. So either one get you an achieved. Alright, next question. What is unrealistic about this graph? Write at least 2 comments of justifications. Okay. Okay. So what is unrealistic? So remember back in the first question, the graph area was doubling each day. So when Hank draws this graph and saying he's going to remove the plant, he doesn't consider the fact that the plant's going to grow back. So he might remove, for example, 25.6 meters squared of the plant on day 1, but then overnight when he and his friends are sleeping, the plant might start growing back. So the next day there might still be more plants than originally planned. Okay, so that's unrealistic. Another part that's another thing that's unrealistic is the fact that they think they can remove exactly 25.6 meters squared of the plant. Okay, because each day unless like each day like he assumes that he's going to remove the exact same amount of plant. Okay, this is unrealistic. Okay, because it's really hard to be able to remove exactly the same amount of plant. Okay, so for example, on day 1 he might remove 25.7, and then on day 2 he might only remove 25.62 or something. So you might not be able to remove the same amount of plant each day. Okay. Sorry. So we're gonna say Hank and his friends may not be able to remove the same amount of plant each day. Will not be able to remove the same amount of plant each day as they may vary the amounts every day due to inconsistencies. Okay, and we're also gonna say that the plant may grow back. Also experience some growth during this time. Hence the graph may experience increase due to the plant going back. And this would not be a linear graph. Okay, so getting 2 comments. So Hank and his friends may not be able to remove the same amount of plant each day, and you're also saying that the plant may experience some growth during in between the time that they are removing the plant. Okay, so both of these comments, okay, will get you an excellent grade. Okay, in terms of getting a merit, you cannot get a merit. Okay, to get an achieved in this question. Okay, so getting an achieved is stating that okay, so getting achieved is being able to relate to removing the plant back to the gradient. Okay, so but to get so you're probably aiming for excellence. So getting excellence. Okay, you're saying that Hank and his friends may not be able to remove the same amount of plant each day. And you're also saying that the plant may grow back, and therefore the graph may experience some increase and decrease, inconsistent decreases, and hence it will not be a linear graph. That will get you an excellence grade for this question. Okay. Alright, moving along. Question 2. The next year, when the plant begins to grow back, Hank tries to stop it from spreading across the pond so quickly. As soon as he notices the plant, he begins removing it. The graph of the area of the pond covered by the plant this year is shown below. So area in square meters, A. okay, and day in D, okay. So how much more area is the plant covering each day? So as you can see, on day 0 it covers 20 meters squared, on day 1 it covers 30, on day 2 it covers 40, day 4 covers on day 3 is 50, day 4 60, etc, etc. So in this question we're just gonna state 10 meters squared, okay. So it's increasing by 10 meters squared each day, and that will get you an achieved. What day will it be when the plant covers 200 square meters if the conditions of the conditions remain the same, okay? So show your working, okay? So basically, as you can see, the y-intercept is 20, okay? And it's increasing by 10 meters squared each day, okay? So you know y equals to mx plus c, right? You know that the c is 20, so c equals to 20 because the graph cuts the y-axis at 20. So when on the 0th day, the plant has covered 20 meters squared, okay? And you know that m equals to 10. M equals to 10 because the plant increases by 10 meters squared each day, okay? So it's increasing by 10 each day. So basically y equals to 10x plus 20. We're going to substitute 200 into the equation and see what we get for, instead of x, we're going to say d, okay? So instead of saying mx, we're going to say md because, days are in d. Days is mentioned in d, okay? So we're going to say that y equals to 10d plus 20. So 200 equals to 10d plus 20. You move the plus 20 to the outside, becomes minus 20. So 180 equals to 10d. And therefore, 180 divided by 10 equals to d. D therefore equals to 18, okay? So we're going to say, as our final answer, we're going to say 18 days here. To get a merit grade here, you're going to say the 18 days with the correct working. So all the working here, okay, that'll get you a merit grade. In terms of getting an achieved grade, you're only stating the correct answer, okay? So basically only this, you'll get a correct answer only. So correct answer only will get you an achieved, okay? After 7 days of removing some of the plant by himself, Hank decides to get help. One friend helps him on day 8 and day 9. The area covered by the plant stays the same for day 8 and day 9. What is the equation of this new section on the graph for day 8 and day 9, okay? As you can see, the graph isn't increasing at all, okay? So it's just staying constant, okay? So therefore, y, we'll just say, y equals to mx plus c, okay? So we're going to say the area equals to md plus c, okay? So, as you can see, it's not increasing at all, so therefore, not d. So therefore, m equals to 0 because it's not increasing at all, okay? So a equals to 0, d plus c, therefore a equals to c. And c, if we can draw back all the way to day 0, intersect at 90, okay? So therefore, our final equation will just be, we'll just say a equals to 90. Okay, so what does this section of the graph mean, okay? So it means that the area is staying the same, okay? And therefore the growth, so each day the plant is growing, right? But then Hank and his friend is also removing the plant, okay? So therefore the how fast Hank is removing the plant is the same as how fast the plant is growing, okay? So we're gonna say, and just to answer this question, we're gonna say the amount of plant remains the same, and the speed of removal by Hank and his friend is the same as the rate of removal, okay? So to get a merit grade here, okay, you have a correct equation, okay, and you'll make 1 point, okay? So correct equation, which is this, and only 1 point is needed, okay? So you can either say the amount of plant remains the same, Or you can say that the rate of removal by Hank and his friends is the same as the rate of increase by the plant's growth. Okay, so just one statement with the correct equation will get you a merit grade. Okay, so merit for a correct equation and 1 point. To get an achieved, you only have the correct equation. Okay, so achieved is only equation. Okay. All right. Next question. 2 more friends come to help. Now the area covered by the plant decreases by 15 square meters each day until the plant is completely removed. Draw a graph on the grid above to show the area of the pond covered by the plant from day 10. Okay. So from day 10, okay, it'll start decreasing at 15 each day as stated by the question. Okay, so on day 11 there will be 75. Then on day 11. Then on day 11, there'll be 60. On day 12, it'll go down to 45. On day 13, it'll be down to 30. Day 14, it'll be down to 15. And then on day 15, there'll be no more plant left, okay? So we're going to connect these dots together, okay? So I'm going to use an arrow, a line to show this because I'm not really good at drawing. So I'm just going to... So it should be a linear graph just going down just like that. Alright, so drawing the correct graph here. Drawing the correct graph, okay, so correct graph looking something like this should get you an achieved, okay. Moving on. On one day, there will be no plant left. So as seen by our graph drawn, okay, on day 15, the amount of plant is 0, okay. So therefore, we'll just simply state day 15, and this will get us another achieved grade. So basically, this is basically just 2 free achieved grades here, okay. So next question. The equation of the line for day 9 onwards is A equals to 225 minus 15D. If Hank's 2 friends is come on day 8, what would the equation of this line have been? Explain your reasoning, okay? So therefore, okay, so if Hank and his friends have come on day 8, okay? So basically, if Hank and his friends had come on day 8, so it will start decreasing on day 9, okay? So it will just be 1 day less, okay? So by the time the area of the plant is 0, then it'll be on day 14 because his friends have come 1 day earlier. So therefore, the plant is finished removing 1 day earlier as well, okay? So basically, we're gonna say, okay, so now 2 things we need to find, okay? So the gradient remains the same, so it still decreases. So still decreases at 15 meters squared per day. So this doesn't change, okay? So the gradient remains the same, okay? So m remains at negative 15, okay? So it's decreasing at 15, so therefore it's negative. And this doesn't change between the 2 graphs, so therefore in both graphs it will be negative 15d, but the y-intercept will change, okay? For the second graph, okay, so we're going to start removing on day 9, okay? So on day 9, it will be 75, okay? You know this, okay? So on day 9, it will be 75. So we're going to draw and plot back the graph, okay? So therefore, on day 9, if we draw the graph back, so 1 day, 2 days, 3 days, 4 days, 5 days, 6, 7, 8, 9, okay? So go back 9 days, okay? So therefore, as of right now, it's 75. Okay, but we're going to find out what is the area covered by the plant on day 0, okay? So therefore, okay, we're going to say negative 15, but instead of negative 15, we're going to say positive 15 because we're drawing the graph backwards, okay? We're going to say 15 multiplied by 9, okay? And we're going to add the 75 on day 9, okay? So it's plus the 75 here. Plug this into your calculator, so 15 times 9. Plus 75 should give you okay, I screwed up, it looks like. They come on day 8. Okay, so I misunderstood the question. So apparently it's even 1 more day earlier. So on day 8 they start coming, so it's shifted 2 days to the left, okay? So on day 8 it will be 75 meters meters squared. Okay, so we're just going to say, instead of 15 times, we're going to say 15 times 8, sorry. And that should give you 195, okay? So therefore, our graph, so our y-intercept is 195, and our gradient is negative 15, okay? So we're going to say the equation is area equals to negative 15d plus 195, okay? I explain your reasoning. The graph is shifted 2 days to the left. Hence our y-intercept will be 30 units less. Okay, so why is it 30 units less? Okay, so you know on the original graph, so the original graph is here. So the original graph, the y-intercept was 225, but for our new graph, it's only 195. Okay, this is because I shifted the graph 2 days to the left. Okay, so therefore Hank and his friends start removing the plant on an earlier day. So therefore, if I draw the graph back, so instead of saying 15 multiplied by 10 days back, we're only going to say 15 multiplied by 8 days back. So therefore, 15 times 2 is 30, so it's actually 30 units less, okay? And getting the correct equation and the correct reasoning, okay, that'll get you an excellent grade here. In terms of getting a merit, it's the correct equation only, so just the equation will get you a merit grade. To get an achieved, to get an achieved is okay. To get an achieved, okay, you've written y equals to 210 minus 15d. Okay, that's the only way to get an achieved. But I know you guys aren't aiming for achieved, so that's not really too relevant. So hope you understand what I talked about in this question. Okay, so we're gonna move on to the next question. Hank had a dream that he and his friends made the area of the pond covered by the plant follow the parabola given below. Okay. What is the equation of this graph? Okay, so simply, okay, we're gonna be using what should we use? Okay, so we're going to use the vertex equation. Okay, so you can either in this case you can either use the vertex equation or the intercept equation. I'm going to show you the vertex equation first. Okay, so as you can see, our highest point. Okay, so our highest point is here, and that is at d equals to 7. So when d equals to 7, our area of the square meters is 85.33. Okay, so we're going to use the vertex equation here. Okay, so the vertex equation is y equals to a x minus p squared plus k. Okay, so p is our x value for our vertex, and k is the y value. Okay, so simply saying that d is the x, so this is the x-axis and the y-axis here. So the x-axis is the days, so the day 7, and then the y-axis equals to 85.33. Okay, so we're gonna say p is equal to 7 and k equals to 85.33. Okay, so we're gonna say y equals to a x minus 7 whole squared plus 85.33. But the thing is, we still need to find the a value here. Okay, so we're gonna substitute one random point, okay, into the equation, and we're gonna find what our a value is. Okay, we're gonna say, for example, we're gonna substitute 14 and 20. So we're gonna substitute days equals to 14 and area equals to 20. Okay, so 20 equals to a x minus 7 whole not x 14 minus 7 whole squared plus 85.33. Okay, now we're gonna say 20 equals to 14 minus 7 is 7 squared is 49, so 49 multiplied by a plus 85.33. So now we're gonna say 20 minus 85.33 equals to 49a. Okay, so now we're gonna say negative 65.33 equals to 49a. Therefore, negative 65.33 divided by 49 should give us our a value. Plug this into our calculator. That should give us a equals to negative 1.33. Okay, so our final equation would be y equals to negative 1.33 x minus 7 whole squared plus 85.33. Okay, and okay, so now I'm going to show you how to do it with the x-intercept way. Okay, so that's how you do it with the vertex equation. Now I'm going to show you how you would do it with the x-intercept equation. It's really similar way. It's similar. Okay, so as you can see this graph, right? So it's gonna continue down. It's going to end up at -1. Okay, so it's gonna touch the x-axis at x equals to -1. Okay, so therefore, okay, we're gonna say y equals to a x minus p x minus k. P and k are our x-intercepts. Okay, so we're gonna say y equals to a x, because our intercept is -1 and it's minus p, a double negative will make a positive, so it becomes x plus 1, and then becomes this is our other x-intercept here, so this is our another x-intercept here, so we're going to say x minus 15. We're going to substitute a random point. We'll substitute the same point. We'll say 20 equals to a x, not x, so we're going to say 20 equals to a 14 plus 1, 14 minus 15. Therefore, 20 equals to a 15 multiplied by -1. Okay, so therefore 20 equals to negative 15a, and therefore 20 divided by -15 should give us our a value. And that once again gives us our a value of negative 1.33. Okay, so therefore we can rewrite our equation as y equals to negative 1.33 x plus 1 x minus 15. So that's our final equation here. And either getting the first equation I showed you or the second equation I showed you, okay, either one of these will get you an excellence grade. Okay, and to get an achieved grade, you're getting the a value correct, or just getting 2 terms correct will get you an achieved. Okay, so like any 2 terms will get you an achieved. Okay, so I'm gonna do question 3 in a separate video because I'm scared that my screen recorder is gonna cut off. Okay, so stay tuned for that. It will be coming out soon. Thank you for watching this video.